a downward sloping ramp is positioned according to the coordinate system shown. A600, B020 and C003 are points on the ramp. So we know that this one is 003, this one is 020, and this one over here is 600. It looks a bit like a 6, so let's just change that. And a lamp L is positioned on top of a post at 225/2. All dimensions are measured in meters. So the lamp here is at 225/2. Determine the Cartesian equation of the ramp. And note they're only giving us 2 marks for that. And that is because they know that we are just going to go and use an E activity for that one. So we want to be in the Unit 3 for vectors. And equation of plane given 3 points, that looks like that will be the one that we want to use. So what we want to do is input for A, 600, and I think I can just hit the finger tool and it will just input the A and take me to the next line. And then B, if I go for 020, and then again hit the finger tool there, should just input that one. And then if we go for C and put that in as 003, that's that, and then I'll hit the finger tool so they're all in, and then at that point I'm going to hit execute. It should take me right the way down to the bottom, and it will give me 6x plus 18y plus 12z is equal to 36. And I can see there's a common 6 there, so I'm just going to divide through x plus 3y plus 2z is equal to 6. And there's my Cartesian equation. At night, the lamp L emits a bright light and illuminates the ramp. The position that is closest to the lamp will be the most brightly illuminated. Determine the coordinates for the point on the ramp that is the most brightly illuminated. So what we want to do here is have a line that goes through the lamp and then meets the plane here at right angles. That will be the closest point. So we want a line perpendicular to the ramp through 225/2. So R is equal to 225/2 plus lambda, and if we go back to the plane, we can see the normal to the plane will be 1, 3, 2. So it's going to be 1, 3, 2 as the direction of this line. Or if you like, what we have there is 2 plus lambda, 2 plus 3 lambda, and 5/2 plus 2 lambda. Now we want the point of intersection with the plane, so we're just going to substitute those in to the plane. And it was x, which is 2 plus lambda, plus 3y, so 2 plus 3 lambda, plus twice 5/2 plus 2 lambda, which is our z, and that must all be equal to 6. So that is 2 plus lambda plus 6 plus 9 lambda plus 5 plus 4 lambda is equal to 6. So how many lambdas do we have here? We've got 1, 10, 14. So we've got 14 lambdas. And we've got 2 add 6 add 5. So that's plus 13 is equal to 6. So 14 lambda is equal to negative 7, giving us lambda is negative 0.5. So if we want the coordinates of the point, we just need to substitute the lambda as negative 0.5 back to here. And 2 add negative 0.5 is going to give us 1.5. 2 add 3 lots of negative 0.5 is going to give us 0.5. And then 5 over 2. So 5 over 2 is 2.5. And add 2 lots of negative 0.5. So take away 1. That is 1.5. If a ball is released from point C and is allowed to roll down the ramp, gravity will cause it to follow the path of steepest descent. Suppose the ball is allowed to roll exactly 1 meter from point C to point P, where S is equal to CP, is the direction of the steepest descent down the ramp. So if we follow this down, if that's the steepest, that must be a right angle. Now, the vector from A to B, that's going from 6, 0, 0 to 0, 2, 0. So if we look at AB, that is negative 6 to 0. And that means that the line through A and B is 6, 0, 0 plus lambda negative 6 to 0. So that is going to be 6 minus 6 lambda, 2 lambda, 0. So the point here, which we'll call N, has coordinates 6 minus 6 lambda, 2 lambda, 0 for some value of lambda which we want to find. Now this point up here is 0, 0, 3, and the ball is going to roll from 0, 0, 3 to 6 minus 6 lambda, 2 lambda, 0. Which means that that vector is 6 minus 6 lambda, 2 lambda, negative 3. Now what we need is for that vector there to be perpendicular to AB. So what we have is 6 minus 6 lambda, 2 lambda, negative 3, dotted with negative 6 to 0 to be equal to 0. Now that's negative 6, 6 minus 6 lambda, plus 4 lambda, that needs to be equal to 0. So we have negative 36 plus 36 lambda plus 4 lambda is equal to 0. That gives me 40 lambda is equal to 36, giving me that lambda is 36 over 40, or 9/10. Substitute that back into this vector here. 6 take away 6 times 9/10 is 0.6. 2 times 9/10 is 1.8. And then we have the negative 3, which hasn't changed. And so what we need is the magnitude of that vector. So that's going to be the square root of 0.6 squared plus 1.8 squared plus 3 squared. And that works out to be 3.54967, giving that to 6 decimal places there. So what we need to do to get the unit vector is divide this vector by this one here, and 0.6 divided by 3.54967 is 0.169. 1.8 divided by that is 0.507, and -3 divided by that is -0.845. And that's the point we want.